focuses or somehow is simplified into this formula. So your F is equal to K, which is the constant value for your electrical charge, with Q1 and Q2, your first electrical charge and the second electrical charge with regards to the distance. So these equations give you the magnitude of the force for your electrical charges. So the force is along the line connecting the charges. So we know that we have positive and negative charges as part of your atom. So you have your protons and your electrons. So basically, or basically from the idea of two opposite charges will somehow attract one another, and two electrical charges that are of the same kind will repulse or somehow will move away from to opposite direction. So that's how we generalize, or that's how we summarize the picture here below. So positive plus positive, the tendency of your charges is to move away. Same goes with negative with negative. But for the case of a positive and a negative charge, their movement or their tendency is to somehow attract one another. Okay, so the unit for Coulomb's law, or somehow the unit of charge, is coulombs, and the K in our general formula, which is F is equals to K Q1 Q2 over R squared, is equal to 8.988 times 10 raised to the 9 power Newton meters per second over Coulomb squared. So, teacher, what does it mean? So this is the constant number, or this is somehow the constant that we use for Coulomb's law. However, there are certain charges somehow in the case of robbing, or when charges, or somehow when charges, or when the movement of the object or the charge slide past to each other, um, the unit used usually is microcoulomb, or a smaller unit, which is equivalent to 10 raised to negative 6 coulombs. So in that case, we also need to identify the charges of our electrons. Why is that so? We know that an atom contains neutrons, protons, and electrons. And in the case of electrostatic forces, the idea or the movement of electrons are somehow, or the movement of both electrons and protons is observed, and is vital in the process. So we know that both electrons and protons have the same charge, because in the idea of an atom, protons and electrons are always equal with one another. So same goes with their electric charge, or their electrical charge. They have 1.602 times 10 raised to negative 19. Okay, so please remember the constant numbers. So for K, or the proportionality constant for Coulomb's law, is 8.988 times 10 raised to 9 to the 9 power. And for electric charge, you have 1.602 times 10 raised to negative 19. Okay, so aside from the idea of your electrons or the charge of your electrons, there is also a difference for the probability constant if we are talking about free spaces. So it's not always that your your what do you call this one, your movement or the electric charge happens here. So there will be cases that it will be on a free space. So for the permittivity of free space, instead of using k as 8.988 times 10 raised to 6, your constant, your k constant would be 1 over pi, uh, uh, which is a free space 0. So teacher, what does it what's the value of that? So instead of 8.988, you use 8.85 times 10 raised to negative 12 as your k constant, because this would be in the case of a free space, or if the movement happens in a free space. Okay. Clear so far? Any questions or clarification so far? Anything that you wish to clarify?
No, teacher.
Or to ask? Brian, you have something to ask?
No, I don't.
No? How about Celine and Vivian?
No, teacher.
Okay. Okay, so none so far. Let's now continue our discussion. So, like what I have said a while ago, we will be applying, or somehow we will be we will be applying our idea of Coulomb's law. So Coulomb's law strictly applies only to point charges, but in exception for superposition, later on you'll see the principle for this. So for superposition, there are multiple point charges existing for a superposition case. So the forces for superposition principle varies from every other charges that can be calculated, uh, and a vector would be added along the process. So in this case, or in this process, there is the application of certain mathematical principles or mathematical methods in solving your said in solving the said units. So for this, you have one F31, you have F31X, and you have F32. So with this, and you have here the what do you call that? F charge. So in this, there would be multiple point charges. So point charges that exist, which means there are multiple forces acting upon it as well. Okay, so later on you'll see the different vector addition. The different vector addition, and how your electric charge moves to different positions as well, or to different directions. Okay, so let's now identify first how does the totality of the net force, or somehow the net force on a charge, if many vectors are present in in the process. So what you need to do is to just add up or summarize, or get the totality of all the forces applied in the process. So whether it contains 5 forces or 10 forces, for you to get the net force, you just add F1, F2, F3, F4, and F5. But keep in mind that it varies based from the direction. Okay, so um, it's possible if they are leaning or they are moving with the same direction, but because if it is opposing or it's in the opposite end, then there would be a different case in that sense. Okay. So in your Coulomb's law or in your vector addition review or in vectors, there would be different positions and different figures or shapes somehow that are formed. Sometimes we create different sets of different sets of shapes, different sets of line segments, and in your in I mean in the formation of different vectors. So for the first one, excuse me. So for the first one, you have letter A. So here you have two forces acting on an object. So you have the F1 and the F2. So in this case, for you to get the F net or for you to get the totality of your forces, you just simply add both of this and you'll already get the F net or the totality of your forces. However, in the cases of B, C, and D, you need different mathematical methods or different mathematical principle to uh, to to solve and to find the what do you call this one, the value for each shape. So let's have letter B. What shape does it produce? Letter B produces what?
Triangle.
Yeah, your letter B produces triangle or a triangular pattern. What kind of triangle is this?
It's random.
What?
I forgot what it's called in English. It's like irregular.
Okay. It's the regular triangle with the 90 degrees angle, right?
Yeah.
So we call it right angle. So this one, so letter B is an example of a triangle. So for us to be able to identify or to solve for the F net or the vector addition property for this, you need to apply the principle in solving triangles, specifically right angle. Keep in mind that we will only be using the Pythagorean theorem. So the Pythagorean theorem is used for solving uh, triangular or problems about triangles, specifically right angle. So here, for us to be able to get the F net of these vectors, we will follow the formula for Pythagorean theorem. Can you still remember the formula for Pythagorean theorem? Anyone?
It's a squared plus b squared equals c squared.
Okay, very good. So it's a squared plus b squared equals c squared. So for us to be able to identify your or for us to be able to look for the proper, not really properties, but for the units, we will follow the a squared plus b squared is equal to c squared, wherein a squared will serve as, for example, your f1, and your f2 will serve as your b squared, and I mean your b and your the longest among them will serve as your c. So for example, this is 10. For example, this would be, let's say this would be half. This will be 5. Then for us to be able to find your what do you call this one, your c, you just perform the operation. So 10 squared would be 100 plus 25. 5 squared is 25. Square root of 125 would be 11.18. So most probably your c would be 11.18. So 100 square root of 25, 125 would be 11.80. So that would be the value of your C, or the value for the third angle. And from there, you will see, or you will now identify, or you will now find uh, the third vector, or the third, they call this one the third angle. Okay, so for a triangular pattern, you'll use the Pythagorean theorem. And for the parallelogram, so for parallelogram, same thing that you will be using. So parallelogram is, or this parallelogram is a contains two right angle triangles. So for us to be able to get the value for the dotted lines, you will still follow the principle, or you will make use of the principle of computing, or the mathematical principle for computing parallelograms. Same goes for letter D. For letter D would be for x and y components, and the sine and cosine method, wherein angles are involved in the mathematical principle. So sine, cosine, if there would be cases that it gives you, or somehow it produces different angles, then you'll use the correct, or the allotted mathematical principle for that. And later on, as we continue our discussion, or as we have a set of examples, we will have, or we will get the said formula, and the said analyzation for each figures. So what's important with this is that you are familiar with the different set of mathematical principle for you to be able to easily answer and easily get the correct units, and the correct number for each vectors. Okay, so let's continue. So can anyone identify what this picture is?
The electric field lines.
Electric field. Very good. So Brian said that this is an electric field. So basically, this picture shows electric field. Brian, why did you say that this is an electric field?
Because it is showing the direction using those lines. It shows the direction of what a positively charged particle will go, where a positively charged particle will go.
Okay, very good. So this picture shows an electric field, because from your just like from your observation, you can see in the picture the movement, or with the use of the lines, where where does the positive charge go, or where does the negatively charged particles go? Is it moving away from the charge, or is it going towards? Or sometimes it is intersecting or interacting with one another. So aside from electrical sources, one thing that we will be discussing would be your electrical field. So electrical field is the force on a small charge divided by the charge. So if a while ago we are talking about force, for electrical field, it involves the force together with the charge it has. So if this is electrical field, or this is electric field, you have the force in it together with the charge. So whether it is a positively charged or a negatively charged, or um, keep in mind that when we talk about electric fields, force and the charge will always be tagging along with one another. Okay, so let's now continue discussing your electric field. So the force on a point charge in an electric field is computed like this. So if a while ago E is equal to F over Q, for you to get the force, you will somehow use the formula Q multiplied by E. So you just simply substitute the values later on in getting the force on a point charge in an electrical field, and you'll get the answer for this. It's easy because it's just a simple equation, but in cases such as superposition principle for electric fields, you had the same way of getting superposition principle. Why? Because in superposition principle, we have said a while ago that it contains multiple point charges. So for superposition principle, you need to get the total number of electric fields involved in the process, or in the movement of the object. So for you to get the for you to get the totality of all the electrical fields, or the all electric fields, what you need to do is just to add them all. So E1 plus E2 plus E3, and so on and so forth. Depending on how many electric fields involved in the process. And one thing that you need to be careful of in computing, or in solving or in solving problems with regards to Coulomb's law, are the following. So generally, in problem solvings for electrostatic force, electric forces and electrical fields are involved. So first, what you need to do is, or what important thing that you need to do is to draw the diagram. So if you are asked to draw, or somehow for you to be able to easily illustrate or easily analyze the problem sets, or the problem solving, you need to draw the diagram properly. So it's important to show all the charges, the signs, the electrical field, the movement of the electric fields, the forces, together with the direction. Especially if you have if you are talking with vectors, and then calculate forces using Coulomb's law. So you calculate it using your general formula, your your K multiplied by Q1, Q2 over R squared for each for the forces. And then for you to get the totality or the F net of the vectors, add all of it, and then you'll get the result, or you get the total electric force acting upon a specific object. So with that, it will be easier for you to solve problems that that includes electrostatics. Okay, so later in the next meeting, we'll compute or we'll get some computations for the said problems. Okay, so your electric field, let's go back to electric field. Electric fields somehow works in lines. So it can be represented by field lines. So that's when the positive charge and the negatively charged particles differ. So if it is positively charged, what can you observe? What can you observe with the direction or the representation of the lines with the positive charge and the negative one?
The positive is going outwards, the negative is going inwards.
Okay, very good. So your positive charge are going outward or moving away, and your negatively charged particles moves inward or somehow moves towards the charge. So individually, they behave, or your positive and negatively charged particles behave like that, which is why in some cases, dipoles or electric dipoles are created. So here in electric dipoles, you have two equal charges. So you have the positive charge and the negatively charged. You have equal charges but with opposite signs. So the tendency for an electric dipole, or the movement of your electric dipole, is to for the case of your positive charge, it moves away, and somehow for the negatively charged, it moves inward. And along the process, it creates somehow a cloud-like structure, or somehow um, uh, a cloud-like structure, or a cloud-like field lines, or the field lines looks like the electron cloud, which represents the interactions between your charges and the attraction or the interaction between your charges. But in some cases, if your charges are opposite with one another, here you can see that the electric fields between two closely spaced. So here you can see that it's somehow a continuous circular pattern. But in a parallel plate, so in a parallel plate, all the positive signs will be in one lane, and the other one will be in the negative one. So here, because it's parallel and it's a closed space, you can see that they only intersect in the middle. There's no moving inward and moving outward of the particles itself. So it means the the electric field somehow is being shared in the middle part of the electric field, which gives you a constant uh, charge, or somehow it becomes constant in the middle. So generally, electric forces and electric fields are interrelated with one another, and they are somehow interacting with one another with the help of certain ideas and certain uh, certain ideas and certain principles in physics and in mathematics. So next meeting, all the discussions and all the principles that we have discussed for today and we have learned for today, such as for vector addition, for superposition, for uh, total net force, will be applied using different problem sets and examples. So next meeting, please prepare a calculator or a scientific calculator if you have. You may use if you have scientific calculators in computers, you may use it because we will be solving some problems that belongs to your electrostatics. Okay? Any questions or clarifications? No? Vivian
No, teacher.
No,
and
teacher.
Brian? Okay, so if none, that would be all for today and have a great day ahead of you. And you may now go to your next.